Thick film dielectric electroluminescent technology is a phosphor-based flat panel display technology developed by Canadian company iFire. Technology Corp.TDEL is based on inorganic electroluminescent technology and has a novel structure that combines both thick and thin film processes. An IEL device generates light by applying an alternating electrical field to inorganic light-emitting phosphors. Traditional IEL displays are bright, very fast in video response time and highly tolerant of environmental extremes. However, the lack of full color capability and large-size scalability has limited their application for the mainstream consumer television market. iFire has addressed these limitations by replacing the thin film dielectric of traditional IEL technology with its patented thick film, high-K dielectric material and structure. The result is a unique flat panel display technology that provides iFire displays with high performance and low cost potential. iFire was unable to develop displays competitive with LCD, plasma and OLED devices and wound up research and development in 2007. Technology. The TDEL structure is made on a glass or other inexpensive substrate consisting of a thick film dielectric layer and a thin film phosphor layer, squished between two sets of electrodes to make a matrix of pixels. It seems complex, but basically it works when phosphors emit light in the presence of an electric field, and because TDEL uses solid-state phosphors instead of liquids, gases or vacuum, it is probably the most sturdy new technology, less prone to shock and breakage during shipping. Color by Blue. In 2003, iFire announced the development of a process, known as Color by Blue, which further simplified the already simple manufacturing process for TDEL. The simpler Color by Blue manufacturing process was made possible by performance improvements to iFire's blue inorganic phosphor. The Color by Blue process achieves luminance and color superior to the previous triple pattern process, as well as increased contrast, better grayscale rendition and exceptional color uniformity across the panel. Color by Blue is based on the physics of photoluminescence. With CBB, iFire's high luminance inorganic blue phosphor is used in combination with special color conversion materials, which absorb the blue light and re-emit red or green light, to generate the other colors. This fluorescence is possible because the photons in blue light operate at higher frequencies than other light, and therefore have higher energy. With optimum color conversion materials, the conversion factors and the color spectrum of the display will exceed the requirements of HD TV systems. Characteristics and marketplace. Besides its durability, TDEL's claim to fame is its low cost of production. According to the makers, TDEL display would have half the capital and manufacturing costs of a similar LCD or PDP. iFire claims TDEL also has picture quality similar to court TVs. The displays are brighter, more efficient, more resistant to contamination during manufacturing, and more resistant to electrical breakdown than their thin film counterpart, but with less dark contrast and contrast in bright lighting. iFire has moved on from a 17-inch prototype to a 34-inch full-color display. Following pilot manufacturing, iFire expected to begin commercial volume production with capacity in the range of 250,000 units per year. Initial planning work for a volume facility is underway, and iFire is reviewing its commercialization strategy with potential manufacturing partners. iFire ceased research in 2007 and all physical and intellectual property assets were sold in 2009. Pros: fast video response time and long life. The display's simple solid-state architecture, insensitivity to operating temperature extremes, scalability and low-cost manufacturing. Cons: unavailable and production stalled.